Okay, so we have this question here. Let me just shrink it a little bit, make it more manageable. You're conducting a test of independence for the claim that there is an association between whatever the row variable and column variable are. So you're absolutely right. The first thing we're going to want to do is input this information into a matrix. So I'm going to go to the matrix menu by hitting second X inverse. Have my matrices there. I'm just going to hit over to edit. I'm going to edit A. Don't hit enter on A because it'll just pull the A up onto the main screen. We want to edit matrix A. And our matrix is going to be 2 by 3, 2 rows by 3 columns. And then just substitute all the numbers in. There we go. Everything looks good. Now I will go back to stat, over to my tests, and I'm going to do a chi-squared goodness of fit test. Oh, sorry, wrong test. Let me get out of there. Boop, 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 boop. Back to tests. We're going to do the chi-squared test, not the goodness of fit. So our observed matrix is the information we put in matrix A. It's the calculator is going to perform the calculations for us and put the expected matrix into matrix B. So you don't want to have anything in matrix B when you run the test. So we're going to hit calculate. And all this gives us right now is the chi-squared test statistic. So I can write that down. That's 0.2437. Okay, but now I need to know, all right, what is the expected observations for this data? So I need to access matrix B. So I'm going to go back to the matrix menu. Now you'll see there's something in B. So if I go down and select B, well, so here's the thing. If you select B and then hit enter, it pops it up like this, and it can be hard to read all of it. So I'm not sure how you get over there. So what I do is I go back to the matrix menu and I go over to edit. I'm going to pretend like I'm going to edit matrix B. So now I can see all the values of matrix B. Okay, so you could copy these numbers down, 49.189, 24.595, and so on and so forth. So you can just copy those numbers down into these boxes, but you already saw the answer. So then it says the resulting squared Pearson residuals. All right. If you're on my open math, instructions on how to find this are right on the main page. So if you drop down chapter 11, you'll see here it says the Pearson residuals in the goodness of fit problems, or the Pearson residuals for don't mind my dog, he's barking at the Amazon guy. The expected matrix can be found in B, and we find each residual by doing observed minus expected squared divided by expected. So I'm just going to copy that over. Observed minus expected. So we'll say O minus E squared divided by E. So for each cell, like cell AX, I'm just going to do the observed 49 minus the expected, which is 49.189 squared divided by the expected, which is 49.189. So we'll just have at that. Clear everything out. So I'll do 49 minus 49.189. I'm going to square this and then divide by 49.189. So this is going to be a decimal, 4 zeros, and then a 7. Okay, and you'll do that for all of them.